Hi guys, today we're going to extend our little puzzle that we had from last time. Before we do that, I'm going to just get rid of the stuff that doesn't really help us at this point. So what we got from last time is we have a prize object, prize actor, that we can collide with to finish the level, as it were. And then we have a pressure plate with which we can collide to enable the prize. So what we're going to do today is we're going to finish the implementation of the pressure plate, because last time we only did half of that. We step on it, it turns itself on, and that's it. It never turns itself off. As we enable that, that means that alone, you can't really complete this puzzle, because if you step on this thing and then step away from it, it's going to set itself to false, as in it's not going to be active anymore, which means the prize will again be invisible, so you can collide, you can do anything with it. So we'll need some way of keeping the pressure plate enabled. And for that, we're going to introduce, we're just going to bring a few cubes in so we can play with them to put them on the pressure plate so that they can keep the plate on. And then we'll see if there's anything else we can add. But first of all, open the pressure plate blueprint. It's as simple as check that we're colliding with a player, set the is pressed to true. Now, since we're going to be allowing other things to also overlap with our pressure plate, we don't really need this anymore. So it's active begin overlap, we set is pressed to true. We're going to add the other one, which is actor end overlap, which is when when an actor stops colliding with the pressure plate, in which case we need to set is pressed to false. That should do it. Now, what I'm also thinking is maybe kind of visually compile save. Remember to always save, otherwise you may lose some stuff if your IDE crashes. I'm thinking is we could move this like lower to kind of indicate that it's being pressed or something. Let's say 1 through 5 is when it's not pressed. When it is pressed, it's going to go to 1, 2, 5. No, that's not visible. 1, 2, 8. Yeah, something like that. 1, 2, 30. 130. Yeah. 135 is up. 130 is down. Is pressed, and then immediately set actor location. Now we're going to be setting absolute position over here, which is not something that you really want, because if we move this somewhere else, then it's not going to work. So keep in mind that you should probably start using relative locations. And what you want to do maybe is when pressed, move it down. When not pressed, move it upwards. I'll use the simple one, which is just set the absolute position. Minus 390, 670. Minus 390, 670, and 130. 130 when it's enabled. And when it's disabled, it's going to go to 135. If you want to use relative position, that's local offset, I think. Yeah, that one. So these X, Y, and Z values are relative to where the actor is currently located. I'll keep this here in case you want to use it. But for now, we'll try this one. Infinite loop detected. What? Oh, okay. Because this thing is going to move the pressure plate out of player's collision box, it's not going to collide anymore. So this thing is called, which then sets it to false, set actor location to move it outwards. We are now colliding again and it moves to here. So what we created is basically an infinite loop. Okay, so how do we demonstrate to the player that we're colliding with this thing? Without changing its location too much. What we could do is maybe we can either move it by 1 unit. I don't think this is going to change much. We can try and set different material, potentially. There's scale that you can change. So there are a few options that we can do. Try cube over here, because that's the mesh that we have for our pressure plate. Set material. I assume we're able to choose, right? What's the default material on that thing? Viewport, cobblestone, smooth. That's a texture. Okay, let's try that. Set material, cobblestone, rough and smooth. Is there any much difference in here? Or pebble and smooth. Let's go with pebble. So this is when we do something. By default, it's not pressed. So when it's pressed, it should go here. And we'll have one more of these to reset it back to default using the same target. But this time, this is going to be smooth, which is the default. Compile, save. Let's try that. So yeah, we're now indicating to the player that something has happened. This thing is true, as in its internal state is true. If we move away, then it goes back to the original material, saying it's no longer on. And you can also see in the distance, the prize becomes visible and invisible as we collide and then stop colliding with this pressure plate thing. That's good enough. It doesn't cause any infinite loops. Now what we'd like to do is to be able to actually complete the level. In order to do that, we need this thing over here. So for starters, let's just say, is this going to work? It's quite important because you don't want to go and start implementing a lot of the potentially complex stuff. What we're going to do today isn't complex. But as a general rule, if you're about to implement something complex, try to find out if this is actually going to work. And that's true for any kind of programming. First of all, we need to make it movable because we want to be able to move it. We need to simulate physics because we want gravity. Generate overlap events. Yes, because the thing needs to be overlappable so that this thing can get notifications of the overlap. And these are all settings setting on this specific cube. It's not a blueprint, it's just a cube that I dragged into the scene graph. So the good news is the cube falls. It starts overlapping with our pressure plate, and the prize is on, so we can collide with it. Now here's an interesting bug, I think. So currently there are two things that are colliding with it, right? If I move away, it's going to send overlap and notification event, in which case it will think that we stopped overlapping with it, right? Yeah, so this is a bug. And you will need to keep track of the number of things that are overlapping with the pressure plate in order to know what the internal state should be. I'll leave it up to you to implement what to rather fix this bug, but the hint would be is to keep number of things that are currently overlapping with it. So you probably need a variable, an int should do it. Okay. As for the implementation of this thing, let's move it away. Let's move it over here, and then we're going to grab it, place it here on the pressure plate, and then enable the prize, which is like a very, common puzzle type that you'll see in many games. You have a plate, some kind of pressure plate type thing. You then have a few objects lying near it. You pick them up, you place them on the plate, and you proceed. So let's do that. We probably want a new key, so new input. Edit, project settings. You'll find input under engine, or you can just search for input. We're going to add a new action mapping. That mapping is going to say something like grab. What's the typical grab key in games? Is it E? Let's go with E. Keyboard E. Or shall we rename this to just use something? It doesn't really matter. So done that. Now third-person character blueprint. These are actually these are available from content, third-person BP, blueprints. That's where we're keeping all the blueprints. Right, all this stuff we don't care about at the moment. So I'm just going to go further down, right click, use. Was probably not the best name because there are so many things that are called use something. It's going to be under action. There we go. Input action events use. So when we press E, what we want to do is grab something if we're not grabbing anything. If we are grabbing something, release it. Right. How are we going to do this? Yeah, I think physics handle is probably the way to go with this one, because these are physics enabled things. So if you do physics handle, it allows you to, well, as it says, utility object for moving physics objects around. And using that physics handle, we can grab certain components. We can also release components, and we can change the position of these components. Now, we need line trace, right? We already covered line traces quite a bit, actually. We've done a lot of interesting things with them. So I'll just very quickly go through this line trace by channel. We're going to start is where the player is, so get actor location. The end of the line trace, or the end of the line, is actor location, its forward vector multiplied by some distance. Get actor forward vector. Multiply that by some distance. Shall we say 150, so quite close to where the player is. And then you need to add the vectors, because that is basically a vector, that is a point. Add vector, and that vector is this one. That gives you the lined end point. Now, what else? So if we're grabbing something, I think we can check the physics handle for whether it's grabbing something. Let's grab this thing here. Get grab component. This is the thing that we are grabbing at the moment. Or null if nothing is grabbed. Good, because we can then check whether it's valid. So if it's not valid, then we grab. If it is valid, we release. So I think that should be the first thing to do, to check if we're grabbing something. And then if it's valid, then release, which is going to call this thing to release component. Okay, these are getting out of hand. No, wait, did not mean to do that. I want to move these things over here. Is valid. Yes, we're holding something. Release this thing that we're holding. If we're not holding anything, then we're going to do all this line trace stuff. So we can figure out what we're looking at, and then if it's something that we can use. So if it's not valid, then go all the way here to to check if we're looking at something, if there's something in front of us. And then this is the data structure that contains all the information. So we're going to break it into multiple parts. And oh, there's even a return value if something was hit. Okay, we might use it. Right, so what do we want to do? We now know, what do we know? Well, we might be colliding with something. And ultimately what we want, I'm just going to drag another physics handle because I don't want to drag the line from over there. And we want this thing to grab component at location. Will do. So this thing should branch because we first want to know if there's something in front of us. If there isn't, then we can't really do anything. So this condition needs to be set to here so that we know we're colliding, we're looking at something. If yes, then grab the thing that we're looking at. And that hit component is this one. Grab location should probably be where the component is located. So get world location. Is that world location? Doesn't say. let's try that and we'll see. Over here, maybe something like that. Yeah, some housekeeping. Okay, so we can grab something and we can release something. Yeah. Compile, save. Let's try this. So if I hit E just generally, nothing happens, which is fine. If I hit E, this thing, is it grabbed? Let's actually do something like, let's actually move it so we know it's being grabbed. We will need on tick because we want to move it every tick, right? Okay, this is getting big. Tick. Yeah, let's do that. So where's my physics handle? I'll just drag another one in. Get grabbed component. Actually, no, isn't there a way to set it directly? Like set, yeah, there we go, set target location. That's what we want. We want to, every time, every frame, we want to take the position of the player, then the forward vector, multiply by some distance so it's in front of us, and then use that as a location for the target that we're holding. Which is essentially that, because it's the same thing. Except maybe hold it closer to the player, like 100. And that just should be called every frame. And every frame we're taking the physics handle that we have and then moving its target location to in front of us. Okay, we might want to disable rotations. Yeah, 100 is probably too close. Let's set it to 150. So it's a little bit further, and that will also match the distance of the raycast, or the line trace. Also, in case your line trace isn't working properly, you can debug it. You can draw debug type for duration, and then you can also set the duration, in which case you're able to actually see your line trace. When you press E, this red line is your line trace. So it goes from the center of the player, and because that's where the position location is, adds the vector, and that's the line that you have. But we already checked that it works, so I'm not going to have it debug draw. E, closer E, yep. So we can collect it. Yeah, so we no longer collide with it, so it's in front of us, which is good. If I press E again, it releases it. That's exactly the behavior that I wanted. That's perfect. So we need to get reasonably close. Press E, and then drop on the pressure plate. And because we already checked the logic behind it without even the collecting and grabbing things, we already know that it's going to work, which is great. Yay, we completed the level in 38 seconds. Okay, I think that is more or less it. So in this video, we looked at the pressure plate's internal logic, which is to set its internal state to use pressed or not pressed, depending on how we collide with it. And we also removed the limitation of just the player collision, so we're now checking against every other actor that could potentially collide with our pressure plate. We added this set material thing so that we can see that there is something happening. It's important to provide some visual feedback to the user, to the player, because they want to know if something that they did affected the game world. Otherwise, it's tricky. It's the same principles like in user interface. If you're loading something, make sure to display something to the back to the user so that they know it's loading and not frozen. Then we talked about a bug that this thing introduces, because it doesn't check how many times something has been overlapping with our pressure plate. So if you add one object on it, it's going to set to true. If you add second object on it, it's going to be set to true anyway, but that doesn't matter. But then if you remove the second or one of the objects, then it will set itself to false, while still having a collision with the second object that we added. So add a variable to keep track of number of collisions and then go from there. We also added a new input for our ability to grab things and release things. We use this physics handle utility object to grab various things in the world. We should probably check if it's something that we want to grab. Like, you don't want to potentially grab like part of the level or something. Then using line trace, which we already talked about to quite an extent, we use line trace to identify what we are trying to grab. We grabbed it at a particular location, and then on each tick, we use the physics handle to move that object that we're grabbing. And that completes this video. Thanks for watching.